Hi all. I had some questions on just particularly radians, like finding the cosine, the sine, the tangent, secant, cosecant, and cotangent of different radians. So let me just pick a few right here. Like one of the questions right here on the review was the tangent of pi sixth. So if I was going to find the exact value of the tangent of pi 6, first of all, for me, I don't know my radians real well. I mean, I do sort of know. I know that pi divided by 6 is going to be 0.52 radians, because pi 6 radians is 0.52. Pi divided by 6 is 0.52. And so what that means is if this is my unit circle right here, this is 1 unit right here, right? Because this is the 1, 0 right here, right? This is the 0, 1. This is -1, 0. And right down over here, this is going to be 0, -1. All right, so 1 unit is going to be this amount right here. So pi 6, what did I say, is 0.52. So, I mean, I don't know, 0.52. What would be 0.52? It's like half, just run half. So it's about this length right here. So it's going to be about that length. I'm trying to put that exact length right here on the unit circle. So it's going to be about this triangle right here. Okay. And I don't, what is it exactly? The degrees exactly? Well, you have to convert. You got to, if you want to know the degrees. And that's actually what I normally do. I'm just trying to help you see the triangle and where it is and visualize it. Pi 6, though, to convert it, to convert from radians to degrees, you just always multiply by 180 over pi. Okay, and that converts from radians to degrees. You could think of it this way too, maybe, to help you kind of think about it. Pi over 6 radians, I could do it like this. Pi over 6 radians, maybe this is a better way to do it, I don't know, over 1, and it's just the cross cancellation that you would use in chemistry too, right? I want to get rid of radians and I want to convert to degrees. So, 180 degrees is pi radians. And so you can just see here, it's 180, it's going to be pi 6 times 180 over pi. So you can see why I'm doing that. I'm hoping that helps that become a little more intuitive of why you multiply by 180 over pi to convert from radians to degrees. Okay, so at any rate, the pi's cancel here, the 6 cancel, and I can see that goes in there, what, 30 times? So I can see that pi 6 radians is exactly the same thing. It's going to be equal to 30 degrees. And that looks, doesn't that make sense? I mean, look at it over here too, just eyeballing it, that's a 30 degree. So this is a 30, 60, 90 right triangle, so therefore I know that this is going to be 1/2 the height right here, and I know this distance right here is going to be radical 3 over 2, because remember we proved that for a 30, 60, 90 right triangle. All right, so the tangent of pi 6 is going to equal, the height divided by, or the sine, you could think of it as the sine of pi 6 divided by the cosine of pi 6, which is radical 3 over 2. And so you can see here it's going to be 1/2 divided by radical 3 over 2, or 1 over radical 3. I don't typically leave my answer like that. You could, but typically I don't like a radical in the denominator, so I make it radical 3 over 3. So the tangent of pi 6 is radical 3 over 3. It is a 30, 60, 90, so again, that's one of the things you're supposed to memorize. If you just memorized it, great. If you need to reason it out, hope that helped a little bit there. Hope that helped. So let me do a couple more of these, like what about like the cosine of pi force, So here's another one, and again, I'm just going to convert it. I would take pi force radians and convert that to degrees, and so it's a 45 degree doing that, right? Pi's cancel, so I can see it's a 45 degrees. So I know that in my unit circle up over here, a 45 degree is going to be my isosceles triangle, right? It's going to be the same, cosine and sine are the same. You could also think of it as pi divided by 4, let's see, pi, wait a minute, pi divided by 4, it's going to be 0.79 radians. So right over here, and I don't know, maybe this is just confusing to you. See, this is 1, right? This is 1 from here to here. So 0.79 is going to be about this length. Do you see? It's from here to about here. Now I'm just going to eyeball that. I'm going to come up over here and say, oh, do you see how that's the same? It's this portion. Radians are always part of the circumference of the circle, the edge of the circle. And so this distance right here, let me do it even in a different color yet, maybe like in this yellow right here. Do you see this distance right here is exactly the same as this distance right here? That's 0.79 radians, or it's pi fourths radians, or it's a 45-degree angle. So I don't know. So the cosine, so basically I know it's a isosceles, so I know it's going to be radical 2 over 2 and radical 2 over 2. So the cosine of pi fourths is radical 2 over 2, right? The sine of pi fourths is also going to be radical 2 over 2, and the tangent of pi fourths is going to be 1. You know, and the cotangent, secant, cosecant are just going to be the reciprocals of those. So hopefully, you know, again, that makes sense for that one. You can't do it exact unless it's one of these, unless it's pi 6, which is a 30 degree, it's pi fourths, which is a 45 degree, or it's pi thirds. So remember, this is a 30 degree, this is a 45 degree, and this is a 60 degree. So that's the other one let's do. Let's make sure you understand pi thirds. All right. So the sine of pi thirds is going to equal, and then once again, just reasoning it out, because I don't like to memorize things, but you should have just had this memorized. Pi thirds is a 60 degree, because again, you know, pi thirds times 180 over pi, pi's cancel, is 60. So you can see the sine of pi thirds is the same as the sine of a 60 degree. So over here, you could think of it this way, okay? This is about a 60 degree right here, right? Also, just thinking of it in terms of radians, which is arc length, it's fraction of the whole circumference. The circumference is 6.28, right? Of a whole circle, the circumference is 6.28. Can I get this to work here again? Here we go. So the circumference of a circle is, and this is the unit circle, so it's going to be 6.28 or 2 pi. You know, 2 pi is just a shorthand way of writing 6.28, okay? Or it's a more exact measurement, actually, which is kind of better. All right, so if I take pi and divide it by 3, I'm going to get 1.047 radians. And so, you know, here's 1 radian right here, right? If this is the circle I'm using, that's 1. That's 1 unit. Okay, so if I just come up here and do that same distance, and it's, you know, this distance here has to equal this distance here, and it does. It, you know, that look, that's not bad. Maybe not great, but if you just wrap this 1 right along here, that's where it is, and it forms a 60 degree. Okay, and I remember that this is radical 3 over 2, and this is 1/2 down over here. And once you remember all those, then it's fairly easy. Okay, so the sine of pi thirds is going to be the height. It's radical 3 over 2. The cosine of pi thirds is going to be the horizontal distance. It's going to be 1/2, right? And the tangent of pi thirds, don't go to sleep. We got a little enough time here, I think. It's going to be radical 3 over 2 and over 1/2. So you can see it's going to be radical 3. And then, of course, the secant, cosecant, cotangent are all just reciprocals of those. Again, that's what I do because I do not like to memorize things. But you could just go back and memorize that chart. And this is just one. These are all ones. When it asks for an exact value, these are all just multiples of 45 degrees, 30, 60, 90. you know, so it's either they're a 30, 60, 90, 45 in the first quadrant, second quadrant, third, or fourth quadrant. It's one of those quadrants when it's exact. I don't know, hope that helps. Okay, bye.